So welcome to session 3 on the Pre-Leaving Cert Algebra Revision course. This video is going to focus on factorising expressions. So not necessarily a question in its own right on a Leaving Cert higher level or indeed a Leaving Cert ordinary level paper, but the ability to factorise is extremely important moving from the junior cycle to the senior cycle, where we're going to need to be able to simplify fractions and solve equations, particularly let's say a quadratic equation where we need to factorize the quadratic expression before we can go on and solve the problem. We're going to base the work around 10 key examples as in the other videos, each one slightly different than the previous. There is 4 main types of factorizing that we will run through, and then the 10 key examples will have a couple of examples of each of those, and there'll also be a couple of examples of each of those in the 10 trickier examples, where we've also adapted some Leaving Cert higher level questions to show how we might use factorizing in a Leaving Cert paper or on a Leaving Cert question. As before, we have the big bank of old questions and solutions from the past Leaving Cert and Junior Cert papers, and I'm just going to spin over there briefly just to maybe run through what that's all about. We've mentioned them in a lot of the videos so far, but people might not know exactly what I'm referring to when I talk about the question bank of questions and solutions. So what you can see on screen here is one of the packs, so specifically the pack for factorizing all types of algebraic expression. That's the pack we're looking at today. And as you work through the document, what you'll see past questions from the Leaving Cert higher level paper, the Leaving Cert ordinary level paper, and so on. So past questions from all of the old papers relevant to this particular topic. There's a menu system at the start, so if you click on any particular level, for example Junior Cert higher level, you'll be brought straight to the questions on that particular topic. So it's a place where once you've done the 10 basic examples, once you've had a look at the 10 trickier examples, you might decide to explore this document further and try and do all of the old questions in this particular topic to kind of store them away and kind of feel confident in your ability to factorize an expression. In this particular session, session 3, I've also subdivided these question and solution packs by each of the factorizing types. So in a minute we're going to discuss common factors, factors by grouping, quadratic factorization, and the difference of squares. And there's a sub pack of questions and solutions for each of those for students who don't want to do all of the factorizing in one go and would like to break it down into smaller chunks to kind of master it before they kind of maybe look at this larger pack where you have to not only solve the question, but you also have to decide what type of the 4 types of factorizing it might be. Okay, so let's spin back over and we'll get started with our examples. So let's discuss the 4 main types of factorizing, the 4 types we would have met in our junior cert and that we'd like to bring with us then into the senior cycle. So the first one, we'll just get them down on paper here, and as we write them down, we'll give an example of what each one looks like without actually exploring it until we look at it on its own in its own separate slide, let's say. So the first type is called common factor. So common factor is where we have some terms in an expression and we're looking, is there some factor or some number that divides evenly into all of those terms. So it could look something like 2x squared plus 6x, and hopefully people can see that there is a number that divides evenly into 2 and 6, and there's also letters that divide evenly into x squared and x, and we'll explore that example further in a few minutes. Number 2 is called factorizing by grouping, and in this type of factorizing we have more than 2 terms, but there's no common factor to all of the terms. So for example, if we had ax plus ay plus bx plus by, we can see that there's no factor other than the number 1 that would divide evenly into these 4 terms. And what we're going to have to do is we're going to have to group them together and then factorize them in groups. And we'll see how that works in an example later on. Number 3 is the most important, I would say, type of factorizing, as is the one we probably see the most often, which is factorizing quadratics. So we can sometimes call these quadratic trinomials. They have 3 pieces in them. Generally, they have an x squared term, they have an x term, and then they have a number term. So something like x squared plus 7x plus 12, this is called a quadratic. And we've met quadratics lots in our junior cert. We know that the highest power of a quadratic is a 2, so it has an x squared term at the front of it. The 4th type we're going to meet then is called the difference of 2 squares. And generally this looks like 2 squared terms and one subtracted from the other. So for example, we could have x squared minus y squared. So that's called the difference, that's why it's a minus, of two squares. And there's a specific type of factorizing we can do for that. So it's also important to recognize that we'll meet more types of factorizing as we move into the senior cycle. So for example, we have difference of two squares. At junior cert level, you'll also see the difference of two cubes and the sum of two cubes, for example, at senior cycle. So let's start with factorizing by common factor. Let's briefly discuss what a factor is again though. So let's say I had the number 2 and I asked you to tell me the factors of 2. I'd be asking you to give me numbers that divide evenly into 2. So for example, 2 and 1. And essentially what I've done there is I've factorized the number 2 and I've split it into the numbers 2 and 1. The number 8 I could factorize into 4 by 2. I could also factorize it as 8 by 1. So essentially that's all that factorize is. It's splitting it up into terms that multiply together to give our original number. As we talk about algebraic expressions, we're talking about the same thing. We're talking about taking an expression and splitting it up into numbers or terms that multiply together to give that expression. It's important to think of factorizing as being the opposite of expanding brackets. If I wanted to get rid of these two brackets, 2 by 1, I'd multiply them. 2 by 1 is 2, and I'd get back to the original number that I had. The same thing with 4 by 2, if I multiply them, I'll get 8. 8 by 1, I'll multiply them to get 8. We've explored this idea previously when we went to simplify expressions and multiply out brackets. So for example, if I give you 2x on x plus 3, and I asked you to simplify this expression, you'd multiply it out. You would multiply the 2x by the x, and you'd multiply the 2x by the 3. 2x times x is 2x squared, and 2x by 3 is 6x. Now 2x and x plus 3, they're the factors. 2x is a factor, and x plus 3 is a factor of this expression, 2x squared plus 6x. So if we want to factorize an expression using common factor, what we're talking about is working backwards and putting it back into the brackets. So factorizing would take an expression and split it into its factors, okay, the things that multiply to give that expression. So let's tackle this question fresh, as if we had been asked to factorize 2x squared plus 6x. Now we know the factorization of 2x squared plus 6x is 2x on x plus 3 because we expanded that to get the expression 2x squared plus 6x. 2x is a factor and x plus 3 is a factor of 2x squared plus 6x. But how would we do it if we were tackling it fresh? Well, we'd have a look at 2x squared plus 6x and we'd decide what was the highest common factor in both of these terms. So treating the numbers and the letters separately, what's the highest number that goes into both 2 and 6? Well, 2 is the highest number that goes into both 2 and 6. Then we have a look at the variables or the letters in the question and we see what letters are common to both terms. So there's an x common to both terms, and so I put that beside the 2. So 2x is a factor of 2x squared. It divides evenly into 2x squared, and it also divides evenly into 6x. I'm going to ask myself the question, well, how many times does 2x go into 2x squared? If I was to divide 2x into 2x squared, what would we be left with? Because that's going to go in the first part of our bracket. Another way of thinking about that is, what would I multiply by 2x to get 2x squared? Well, of course, I'd multiply an x by a 2x to get a 2x squared. So if you divided 2x into 2x squared, we get x times. What about if I divide 2x into 6x? So again, another way of thinking about this is, what would I have to multiply by the 2x to get a 6x? Well, clearly I'd have to multiply 3 by 2x to get 6x. 2x, if I divide it into 6x, gives me 3. And that's the factorization done. I've divided it into its two factors. 2x is a factor of 2x squared plus 6x, and x plus 3 is a factor of 2x squared plus 6x. How would I go and prove that this is the answer? Well, if I multiplied it back out, I should get the original expression. So 2x by x is 2x squared, and 2x by 3 is 6x. And that's all factorization is. It's taking an expression and dividing it or splitting it up into its factors. Let's have a look at another example. What if I had asked to factorize 15 AB minus 25AC. So how would the factorization in this question work? So again, we're looking at numbers that divide evenly into 15 and 25. And the biggest number that goes into both 15 and 25 is the number 5. Then we have a look at the letters. We have AB in the first term and AC in the second term. And what's the letter that's common to both? Well, A is common. So 5A is going to be one of the factors outside of the bracket. Then we open up a bracket and we ask ourselves the question, what's 5A into 15AB? So in other words, what's 15AB divided by 5A? So I like to do it separate, the numbers first of all. What's 5 into 15? Well, 3. And what's A into AB? What do we get if I divide AB by A? Well, I get B. Then moving along to the second term, what's 5 into 25? 5 into 25 goes 5 times. And then what's A divided into AC? Well, if you divide AC by A, you'll be left with C. Now, is this the factorization? Has this been factored correctly? Well, let's multiply it out to see. 5A by 3B is 15AB. And 5A times minus 5C is minus 25AC. So factorizing by a common factor only works when there's factors that go evenly into all of the terms. And when there's factors that go evenly into all the terms, then we can take that factor outside of a bracket and use division to decide on the other factor then. We're going to see in the next example by grouping that sometimes there won't be a common factor to all of the terms. So we're going to try and factorize an expression with 4 terms in it. So the expression is AX plus AY plus BX plus BY. And what we'll first see is that there is no common factor to all 4 of these terms. Obviously, with the exception of one can divide evenly into all of these terms. But in terms of other numbers or letters that are in all 4 of the terms, there's none. We can see that there's X's in the first and the third term. There's Y's in the second and the fourth term. There's A's in the first 2 terms. There's B's in the second 2 terms. So there is lots of common factors, but no one common factor that goes evenly into all of the numbers. To see how we might have arrived at a situation like this, let's come over to the right-hand side and we're going to multiply out or simplify the following algebraic expression. So if I had been asked to simplify, and we had A plus B on X plus Y. So remembering how we expand 2 sets of brackets like this, we open the first bracket, so we have A on X plus Y plus B on X plus Y. And then multiplying this out, we have A by X is AX, A by Y is AY, B by X is BX, and B by Y is BY. And you can see that when I multiply out the expression A plus B on X plus Y, I get the expression that I'm asked to factorize up here on the left-hand side. And so the question becomes, how am I going to work backwards and put this back into brackets? So I'm going to factorize this expression by grouping them in pairs. So what I'm going to do is I'm going to take the AX and the AY together and see can I factorize something out of those 2 terms, and then I'm going to take the BX and the BY and see can I factorize something out of those 2 terms. So taking AX and AY, I can see that there's no number common obviously other than the number 1, but letters, I have AX on the left and AY on the right, so A is common to both, and I'm going to take that outside of a bracket. That's my first factor of AX and AY. That's a common factor to AX and AY. I'll open up a set of brackets. Now, what do I get if I divide A into AX? Well, AX divided by A is X. Plus, what do I get if I divide AY by A? I get Y. So I've treated the first 2 as a pair with a common factor, and I've taken out A, and I have A on X plus Y. Now, my second 2 terms, well, obviously the common term here is B. If I divide BX by B, I get X. And if I divide BY by B, I get plus Y. Now, a way to know you're on the right track with these questions is that the brackets should have the same terms inside of them. So X plus Y is in the first bracket and X plus Y is in the second bracket. And that tells me that I'm on the right track in terms of factorizing this expression. To finalize it, I just want to wrap it all up. And how I wrap it back together is, if we think of this over here on the right hand side, Well, the A and the B were opened up originally to multiply out my expression, so I'm going to wrap them back up into a bracket. So the A and the B get wrapped back up into a bracket, and obviously that's going to be multiplied by the x plus y. So my original expression was ax plus ay plus bx plus by, and I factorized an a out of the ax plus ay and a b out of the bx plus by, and then I was able to wrap it back up. The opposite of what I would do is if I was expanding a bracket. And so a plus b on x plus y is the factorization of ax plus ay plus bx plus by. Now what you'll notice with this example was it was in the perfect order for me to do this. When I factorized out my common letter, the brackets had exactly the same terms inside of them. This might not always be the case. So in our second example, we'll have an example of factorization by grouping where we first need to rearrange the order of the terms in the expression. So let's have a look at that one. So here I'm going to factorize 3ab minus 8cd plus 4bd and then minus 6ac. So this is my expression, and I'm asked to factorize this. Now what we'll notice this time is that first of all, obviously there's no common factor to all four of the terms, so we may be able to use factor by grouping in this. But if we take the first pair here, I notice that there's nothing common here. There's no common factor other than one of 3 and 8, and there's no letter common. We have an a, b in the first term and a c, d in the second term. So what I'm going to do with this expression first of all is I'm going to rearrange it to see if the pairs can be reordered. So let's rearrange the expression. So again, I'm going to start with the 3ab, but I'm going to have a look across the line and see is there a term that could better go with the 3ab to treat it as a pair for us to remove a common factor or to divide in a common factor. The term that seems to most closely resemble 3ab is the minus 6ac. I can see that it will have a common factor of 3, but it will also have a common factor of the letter a. Now, the 4bd is obviously going to go with the 8cd because obviously they have a common factor of 4 and they also have another common factor of d. But what's really important here is to have a look at the two factors that we've written down already and to have a look at the leading number. Because 3 is smaller than 6, it's important that when I rearrange the next two terms that I have the smaller number first. So I'm going to have 4bd before I put down the 8cd. If we don't do it like this, then our brackets won't be exactly the same. One of the brackets will be backwards than the other, and so it's just a good idea to do this at the start. It would be no problem to have the 8 before the 4, but if the 8 came before the 4... Now, had we started with the minus 6ac and then had the 3ab, well then we'd have big number, small number, and then I'd have to make sure that it was the 8 that came next and then the 4 after it. So we'll do it another way in a second to show that we get the same answer, but it's just important that when we're rearranging the terms, that if we have a small number first and a larger number second, we have to make sure that the third number is smaller than the fourth number. Okay, so let's have a go at the factorization of this. So taking the first two terms and identifying a common factor, well, 3 goes into both 3 and 6, and a goes into both 3ab and 6ac. So I'm going to take a common factor of 3a outside of a bracket. What would I multiply by 3a to get 3ab? Or another way of saying it is, what's 3ab divided by 3a? Well, b. And then what's minus 6ac divided by 3a? Well, minus 6 divided by 3, first of all, is minus 2. And then if you had ac and you divided a into that, well, you'd be left with c. To double check that, 3a by b is 3ab, 3a by minus 2c is minus 6ac. So it's no harm sometimes just to do a quick check before you go too much further. Plus, what numbers divides evenly into 4 and 8? Well, the number 4. And then is there letters common to both terms? There is a d common, and then we can open up a bracket. If we divide 4bd by 4d, we get b. And if we divide minus 8 by 4, we get minus 2. And then cd divided by d is c. So some people like to divide the numbers separately and then the letters separately, but it is no harm if you're quite good at these to just say something like 8CD divided by 4D is 2C, just that you know you can do it separately or you can do it all at once. Now finally, what's the last step? Well, remember in the last example, we need to wrap the 3A and the 4D back up. It's the opposite of opening the brackets in multiplication. We're wrapping them back up into a single bracket. So 3A plus 4D on B minus 2C is in the other bracket. So remember, expanding brackets, we'd be opening this first bracket and multiplying it out. And so obviously when we're finishing the sum here and we're factorizing, we need to wrap that back up. So the 3A and the 4D get wrapped back up like this. Okay, let's have a look at another example of doing that same question, having taken different terms together. So is there a different way we could have rearranged it? Let's write down the 3AB again, but let's just say for argument's sake that the 4BD could pair with that because B is in common. Well, if we have small, which is 3, and then big, which is 4, we need, of the remaining terms, to put down the smaller one, the 6AC, and then we have the minus 8CD. Now, will this work? Well, B is common in the first two, so that's a pair that would work. And then 2 will divide into 6 and 8, and C is common as well. So even though this is a different order than I did originally, we might still get the same answer if we do it this way. So let's take a look. We're going to take out of the first pair, we are going to divide out B. B is the common factor. B into 3AB goes 3A times. And then B into 4BD goes 4D times. If we divide B into 4BD, we'll be left with 4D. Now, what's important when we have two minuses then following as the last two terms is we write down whatever sign is in the question. So I can see here that this is a minus. It's a good strategy just to write down the minus next. Now, what number goes into 6 and 8? Well, the number 2. And is there any letters common in AC and CD? The letter C. I'll open up a bracket. What do I get if I divide minus 2C into minus 6AC? Well, minus 6 divided by minus 2, first of all, is plus 3. And then C into AC will be A. What about minus 2 into minus 8? Well, minus 2 into minus 8 goes plus 4 times. And then what about C into CD? That goes D times. Now, we know we're on the right track because, remember, our brackets are the same here. So I'm going to wrap the B minus 2C into one bracket. And then I have the 3A plus 4D in the second bracket. Now, is this the same answer as we got originally? We had two factors originally of 3A plus 4D was our first factor and B minus 2C was our second factor. And in this example, B minus 2C was our first factor and 3A plus 4D was our second factor. And this is fine. Remember, 4 times 3 is exactly the same as 3 times 4. So even though the brackets are in a different order here, we have still the same two factors. And so the factorization is correct. So the rearrangement is obviously an important thing to do, but sometimes there's different arrangements that can take place to get us to exactly the same answer. Okay, so that's our factorizing by grouping, and you'll see another couple of examples in our 10 examples coming up later on. Okay, so our third method of factorizing is going to look at factorizing quadratics. So we're going to factorize something like x squared plus 7x plus 12. So something where the highest power is a 2. So something with a highest power of 2 is called a quadratic. So this is a quadratic expression. Now I've called it trinomial because there's 3 parts to it. And just to distinguish between factorizing a quadratic that doesn't have 3 parts in it, that might have 2 parts in it. So if I had this expression here on the right hand side, x squared plus 8x, this is a quadratic. So a quadratic doesn't have to have 3 terms in it. It just has to have a highest power of 2. But how would you factorize this? Well, this is just a common factor as we've seen already. Is there any number that goes evenly into both these? Well, no, other than the number 1. But the letter x is in both x squared and in 8x. X into x squared is x, and x into 8x is 8. So factorizing this quadratic, x squared plus 8x, is simply using a common factor. And this is a very different method than we'll use to factorize a quadratic trinomial where there's 3 pieces in it. So we have a specific method that we would use to factorize quadratic trinomials as opposed to a quadratic that has a common factor in it like this. Okay, so let's get rid of that and let's have a look at our method. So as before, let's see how we may have arrived at the x squared plus 7x plus 12 having started with 2 sets of brackets, x plus 4 times x plus 3, and given a question in an earlier video where I would have asked you to simplify x plus 4 on x plus 3. So how would we have done this? We'd have opened up the first bracket, x on x plus 3 plus 4 on x plus 3, and then I'd have multiplied it out and I get x by x is x squared, x by 3 is 3x, 4 by x is 4x, and 4 by 3 is 12. And then finally we can see that 3x and 4x are like terms, and we could add 3x and 4x to give us 7x. And so that's a question we may have seen in an earlier video where I would have asked you to expand a set of brackets. And what we're going to do now is we're going to see how we can take this final answer down here, x squared plus 7x plus 12, and factorize it so to get back to the original algebraic expression with the 2 brackets multiplied by each other. So we're going to do it in one line. The method we're going to use is called trial and error. And this is a topic that differs greatly between schools and between teachers. So we're going to use trial and error anytime we see a quadratic expression. Oftentimes you'll hear teachers talk about what's called the guide number. And if you've learned the guide number method and you're happy with that to factorize a quadratic, that's absolutely fine. But we're going to use what's called the trial and error method. So if I was given a quadratic trinomial like this, what I would do is I would do 2 sets of brackets, with each bracket going to contain 2 terms, like my final answer up here. Now, the trial and error method that we're going to use requires us to obey 3 basic important rules. And if we obey these 3 rules, we actually can't make a mistake with the factorization. Okay, if we break some of these rules, then obviously we'll get it wrong. But if we obey these 3 rules, we won't make a mistake in the factorization. Now, the first rule says that the first term in each bracket must multiply to give the x squared, the first term in the quadratic expression. So what are the only 2 things that multiply to give x squared? Well, x times x gives x squared. If that was a 2x squared up here, well then I'd have to multiply 2x by x. So the second rule then says that the last term in each bracket has to multiply to give the last term in the expression, the constant, the term without an x in it. Now, there's a number of things that multiply to give 12, so I think it's helpful on the side of the page to write down the number 12, and then underneath it write down what multiplies to give 12. So it could be 12 and 1, it could be 6 and 2, it could be 4 and 3. So they're all the factors of 12. So with absolute certainty, we can say that this is either going to be 12 and 1, 6 and 2, or 4 and 3. And this is where the trial and error method comes in. So I'm not sure which of these pairs it is yet. Now the last rule is probably the most complicated. It says that if I multiply the inner terms here by the outer terms here and add them together, that gives me the middle term of my quadratic, the 7. So what I have to do is I have to decide which of these 3 pairs of numbers, 12 by 1, 6 by 2, and 4 by 3, if I put them into the latter part of each bracket, would also combine to give the 7x. So they're going to multiply to give 12 and somehow combine to give 7. Now I'm going to purposely pick a wrong answer. So what I'm going to do is I'm going to pick 12 times 1. So what we're going to do is let's run through the 3 checks. So the first part of each bracket, x by x, gives me x squared. So that's fine. The last part of each bracket, 12 by 1, gives me 12. So that's fine. And let's try the third part now to see if it works. The inner 2 gives me 12x when I multiply them, and the outer 2 gives me 1x when I multiply them. But there's absolutely no way that I can combine 12x and 1x to give me 7x. So it's not the numbers 12 and 1, and so I'm going to erase them. So some people like getting a pencil for these and rubbing it out when their trial has gone wrong and they have to try something else. So I'm going to try now 6 and 2. Now let's run through the 3 checks again to see if 6 and 2 is the solution. So the first part of each bracket, x by x, is x squared. That's fine. The last part of each bracket, 6 by 2, is 12. That's fine. The inner 2 multiplied to give 6x, and the outer 2 multiplied to give 2x. And is there any way that 6x and 2x can give me 7x? No. And so my second trial has failed as well. And so I'm going to rub out the 6 and 2 and then do my last trial. So I now know that 4 and 3 is going to be the answer, but we still have to go and check it. So let's put in 4 and 3. Now let's run through the 3 rules once again. First part of each bracket, x by x is x squared. Fine. Last part of each bracket, 4 times 3 is 12. Fine. Multiplying the inner 2, we get 4x. Multiplying the outer 2, we get 3x. And 3x and 4x can combine to give me 7x. So I know with certainty that 4 and 3 are the numbers in the brackets. So I'm going to write down the inner 2, 4x, and the outer 2, 3x. Because the last thing I have to decide is, what do I do to a 4x and a 3x to somehow give me plus 7x? Remember that there's a plus here with the 7. So if you had a 4x and a 3x and you want to make up a 7x, you add 4 and you add 3. And so the signs in this question are plus and plus. Now, as you get better and better at these, you obviously don't have to write down all these colours or put in this much effort. Most people can do these quite easily in their head. If I saw this question on a paper and I was asked to factorise x squared plus 7x plus 12, I'd open up 2 sets of brackets, bracket, 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 bracket. What 2 numbers give me x squared? X and x. What 2 numbers can multiply to give 12 and somehow combine to give 7? Well, I know it's going to be 4 and 3. And then I know that plus 4 plus 3 is 7. So it can be done as quickly as that, but we're looking for a method that will work for the more complex ones. We'll see a more complex one in a second where there's more options, but to have a method that always works is very important. Again, if you're used to using the guide number method, I recommend continuing with that, but it is important to be able to factorize a quadratic above probably any of the other factorizations. And a lot of people don't learn it, they kind of skip it and fall back on other methods to solve quadratic equations, which in Leaving Cert Honours level maths won't help them in the long term when they get sort of advanced questions where you won't be able to use particular formulas or whatever it might be. So this next version is a little more complicated. We have 2x squared minus 5x minus 12, and we're just asked to factorize this quadratic expression. So I'll just put down an equals and then we can talk about it. Okay, so what makes this a little more complicated is that we have a number in front of the x squared. That always adds to the complexity a little bit, but we're going to run through the process in exactly the same way. We know that when we're factorizing our quadratic trinomial, we do 2 sets of brackets. And most people can just launch into this now using trial and error to try solutions. So for example, I know that 2x by x are the only 2 things that multiply to give 2x squared. So what I don't know, however, is it going to be 12 and 1, which multiplies to give 12? Is it going to be 4 by 3, which multiply to give 12? Is it going to be 6 and 2, which also multiplies to give 12? So there's a lot of combinations of what the numbers could be. Some people can store all the information in their head and factorize this within a couple of seconds. And other people might have to go through the process we're going to go on the right hand side to just check our solutions. So I'm going to put the 3 terms in different colors. I'm going to put the 2x squared in purple. And then I'm going to put the minus 5x term in green. And then finally I'm going to put the constant, the minus 12, in blue. Now you might be saying, why am I going through all this? And again, it's just to highlight exactly what's happening in each piece of the factorization. And then I'm going to put my 2 sets of bracket underneath. So I know that the first term in each bracket has to multiply to give 2x squared. And so sometimes, again, it can be helpful on the side, just write down 2. And then what are the only 2 things that multiply to give 2? 2 by 1. So I know that it's going to be 2x by 1x. 2x times 1x is 2x squared. And we already knew that from over here without having to do any of the trial and error work. The next thing I know is that the second term in each bracket has to multiply to give 12. And there's lots of things that could multiply to give 12. So I write 12 on the side, and I'm going to try 12 and 1. I'm going to try 4 and 3. I'm going to try 6 and 2. Some people will straight away know which combination of these numbers it's going to be. The last rule that has to be obeyed is when I multiply the inner two terms, here and here, by the outer two terms, here and here, that has to give me the minus 5x. And I'm just going to throw that down on the bottom. So which combination of 12 and 1, 4 and 3, and 6 and 2 is it going to be? I'm just going to have to go and try them. If I can't store the information in my head, I just have to go and try them. So I'm going to try 12 and 1. So let's run through the 3 checks to see, is it going to be the numbers 12 and 1? So the first part of each bracket, the purple, 2x by x gives me 2x squared. That's fine. The latter part of each bracket, the blue, 12 times 1 gives me 12. So that's fine. And then if I check the inner two multiply to give 12x, and the outer two multiply to give 2x, and can 12x and 2x give me 5x? Well, they can't. So I know that it's not the numbers 12 and 1 in that order. Now, you could go and try 1 and 12, so they can be the reverse order. But I'm just going to try different two. So I'm going to try 4 and 3. And some people might be saying this is a very long, drawn-out process. As you improve at these, you won't have to write down all the colours, you won't have to write down all the factors. You'll start being able to do it in your head, the more practice you get at them. So let's try 4 and 3. The purple, 2x by x is 2x squared. That's fine. The blue, 4 by 3 is 12. That's fine. The inner two multiplied by each other give you 4x. The outer two multiplied by each other give you 6x. And again, unfortunately, 4x and 6x don't give me 5x. So I'm intentionally doing these wrong so that we can try out the trial and error approach. And I'd be hoping that as people improve, they can just look and see what the correct answer might be. I'm going to reverse those, and I'm going to put 3 in the first bracket and 4 in the second bracket, and eventually we'll have finally landed on our solution. So the inner terms, 3 by x give me 3x, 2x by 4 give me 8x, and 3x and 8x can combine to give me minus 5x. So the last thing is just how we get our signs. So if I had a 3x and an 8x, how would I get a minus 5x? Well, I'd have to do plus 3x minus 8x gives me minus 5x. So it's plus 3x, the inner, and minus 8x, the outer. Now, this is a harder version. Again, it's just to explore how this is a foolproof method that does always work, even though sometimes it can be quite time consuming. So let's just check our 3 rules to make sure that this is the right answer. So the purple, 2x by x is 2x squared. The blue, 3 by 4 is 12. And then the inner two give me 3x, and the outer give me 8x. And if I have plus 3x minus 8x, so plus 3x minus 8x, I get minus 5x. And so this is the final solution. And just to stress, I would be hoping that you could tackle this sum here by just opening up the 2 sets of brackets, maybe doing a small bit of rough work on the right hand side, and more quickly than we've just done there, being able to say, well look, it's plus 3 minus 4. And having a pencil at hand so that when you do your 3 checks, you can quickly rub out the 3 and 4 and switch it around to something else if they aren't the 2 numbers that work in the latter part of the bracket. Okay, we'll see 2 more examples of those in the 10 basic examples, and there's also, like I mentioned, tons of quadratics in the past solution packs, and I really would recommend practicing those, as factorizing quadratics is an extremely important skill. So let's take a look at our final example of factorization in this lesson, which is factorization of an expression that has the difference of 2 squares. So what we're looking at is we'll have 2 terms. So let's say the first one is x squared, and we have a second term that is 25, and there's always a minus in between these type of expressions. So it's the difference. The word difference, in other words, is minus one term subtracted from the other term, and both these terms here are things that have been squared. We can see that x squared is the number x that has been squared, and 25 is the number 5 that has been squared. So that's where the name comes from. It's an expression containing the difference of 2 squares. Now, as we did in the other examples, let's first of all have a look at what type of expression would expand to give x squared minus 25. So if we had an x plus 5 multiplied by an x minus 5, and you were asked to simplify or expand the brackets on this, what we would do as usual is open up the first bracket. So we have x on x minus 5 plus 5 on x minus 5. So we've opened the first bracket and we're going to multiply each term in the first bracket by each term in the second bracket. So x by x is x squared, x times minus 5 is minus 5x, plus 5 times x is plus 5x, and then plus 5 times minus 5 is minus 25. Now what you'll notice here is, unlike the previous quadratic, we have two x terms that end up cancelling each other out. We have a plus 5 and we have a minus 5, and that gives us 0. And so the end result of multiplying out these two brackets is that we have x squared minus 25. And we'll notice that there's no x term in this. There's an x squared term and there's a number term, but we have no x term. So this is still a quadratic expression. The highest power of x in the question is 2. And we set it up similar to the way we would have done the previous example on quadratics. So we do two sets of brackets. Most people find these very straightforward. Once they spot that it's two numbers squared and it's separated by a minus sign, all they have to identify is what's the number being squared, or what's the term being squared to give the x squared, and what's the term being squared to give 25. Whatever's being squared to give x squared, we put that in the first part of each bracket. So x times x is clearly x squared. And whatever's being squared to give the 25, we put that in the second part of each bracket. So 5 by 5 is 25. 5 squared is 25. So the terms in each bracket are actually identical. But the way we finish this question is that the signs are always different, a plus and a minus. And that's what enables the cancelling out through the multiplication. We had a minus 5x and a plus 5x, and so the signs in the brackets need to be different so that those terms cancel out, and leaves us with no x term. If you wanted to do the check we did in the previous example, it would work. X times x is x squared, 5 times 5 is 25, and then the inner two, plus 5x, and the outer two, minus 5x, give you 0, and that's why there's a 0x term in this question. So there's no need to do that check with the difference of two squares. As mentioned, it's fairly straightforward to see that. You'll sometimes see the solution written like this, and this helps some people identify what's going to go in the first and second part of each bracket. So x squared 25 is our expression, and some people like on the next line then to write down an x in a bracket squared, showing that it's the x that's being squared to give an x squared. Minus, well, what's being squared to give 25? There's a 5 being squared. So some people add in that additional line, and then on the next line, when they have their two sets of brackets, they can quickly translate each of these. So x in the first part of each bracket and 5 in the second part of each bracket. And then obviously a difference of two squares, factorization, always contains a plus and a minus. Okay, so let's do one more example of one of those. Let's look at something slightly trickier. So we'll just erase the right hand side here. So let's take a look at factorizing. So factorize 9x squared minus 25y squared. So what we're going to do again is we're going to put an equals underneath and immediately put in two sets of brackets. So what's the term that's being squared to give 9x squared? Well, 3x by 3x is 9x squared, so 3x all to be squared is 9x squared. What's being squared to give 25y squared? Well, 5y multiplied by 5y, or 5y all to be squared, is 25y squared. And remember, the difference of two squares is always a plus and a minus. If we had wanted to do that additional line where we identified the term being squared, we would have just written down that 9x squared is 3x all to be squared, minus 25y squared is 5y all to be squared, and then we do our two sets of brackets, and we put down a 3x in the first term in each bracket, and a 5y as the second term of each bracket, and then we throw in our plus and our minus. Okay, so with our 4 types of factorizing covered, what we'll do is we'll look at our 10 basic examples, which will hopefully reinforce the learning or the revision that we've just had, and push it on with a couple of extra examples of how we might have a twist on the question of factorizing as well. So having revised the different types of factorization we would have looked at Junior Cert, we can go through the 10 basic examples a little quicker. What we'll do is we'll identify each type of factorization as we come across it, and then we'll run through the solution, and if there's variations or alternate methods of the solution, we'll have a look at those as well. So the first question asks us to factorize 7ab plus 9b, and I can see that there's a common factor to the term 7ab and 9b. There's no numerical common factor. The only number that goes into 7 and 9 is 1, but I can see that there's a b contained in both terms. So I'm going to factor out the b, and if I divide b into 7ab, I'm left with 7a, and if I divide b into 9b, I'm left with 9. So in this question, we had a common factor of b, and so this is a common factor type question. Example 2, we are asked to factorize 9x squared minus 12xy, and again we can see that this is a common factor question. First of all, I can see that the number 3 divides evenly into 9 and 12, so 3 is the highest common factor of 9 and 12, and I can also see that both terms contain an x. So if I was to factor out the 3x from the 9x squared, that means what's 9x squared divided by 3x? 3x into 9x squared is 3x. And what's 12xy, or rather minus 12xy, divided by 3x? Well, minus 12 divided by 3 is minus 4. And then what's xy divided by x? We have a y. To test these solutions, we can always just multiply them back out. 3x by 3x is 9x squared, and 3x times minus 4y would be minus 12xy. And so this is our second common factor question. And here we have a common factor of 3x. 3x is a common factor to both 9x squared and minus 12xy. The next example, we can see that there's 4 terms. Generally, when we have 4 terms, it's going to be a grouping question, though it might not always be. So let's write down the expression first of all. We have 12b squared minus 8ab plus 9bc minus 6ac. Now, to test whether this is a grouping question, what I'm going to do is I'm just going to see, is there any common factor in the first 2 terms? And I can see that the number 4 goes into both 12 and 8, and b goes into both b squared and b. And in the second 2 terms, I can see that 3 would go into both 9 and 6, and c would go into both 9bc and minus 6ac. So this is a factor by grouping question. So we'll just get that down. So it's a factor by grouping. So we're going to take them in pairs. So taking the first pair and factoring out the highest number that goes into both 12 and 8, we have 4. And factoring out letters that are common in 12b squared and minus 8ab, we can factor out a b. Now, 12b squared divided by 4b is 3b. And then minus 8ab divided by 4b is minus 2a. Or you can do the numbers and the letter terms separately. Minus 8 divided by 4 is minus 2, and ab divided by b is a. The next 2 terms, or the final pair, what we're going to do is we're going to factor out a 3. 3 goes into both 9 and 6. And we're going to factor out the letter c, which is contained in both the terms. So if we divide 9bc by 3c, we get 3b. And if we divide minus 6ac by 3c, we get minus 2a. Or again, we can say minus 6 divided by 3 is minus 2, and ac divided by c is a. We know we're on the right track as the terms contained within the brackets are identical, and that's a good sign that you've done the factorization correctly. So what we do to finish the question is we wrap the 4b and the 3c back up into a bracket, 4b plus 3c. So that's the opposite of opening a bracket as we do in multiplication or expanding brackets. And then we put the 3b minus 2a in the other brackets. Okay, moving along to question 4. So 4 looks like it's going to be another factor by grouping question. We can see we have 1, 2, 3, 4 terms. And whilst the order doesn't look correct, we can see that there's 5s in both the first and the last term, and 8s in both the second and the third term. So it looks like it's going to be a factors by grouping question. So we may need to reorder it. Always write it down in the order it's given first of all. So we have 5xy minus 8x minus 8b plus 5by. So what we want to do is we want to change the order so that the pairs that go together are beside each other. So 5xy, I'm going to write down first, would be a better match with plus 5by, as we can see that they would have a common factor of both 5 and the letter y. We can see that we have an x in the first term and a b in the second term. So I just have to make sure that the 8x goes first and then the 8b. If I had written the 8b first, well then my brackets wouldn't have the same order as the factorization of the first pair. So obviously we can take out 5 as the highest common factor there number-wise, and then letter-wise there's a y in both terms, and so we'll factor out a y as well. If you do 5xy divided by 5y, you're left with x. And if you do plus 5by divided by 5y, you're left with plus b. Moving on to the second pair, we can see that the common factor in this case is minus 8. So I'm going to factor out a minus 8. Now if I divide minus 8x by minus 8, I'm left with x. And if I divide minus 8b by minus 8, I'm left with plus b. So as in the previous example, I know I'm on the right track because my brackets are identical. So what I'm going to do to finish the question is I'm going to wrap the 5y and the minus 8 back up into a bracket. Again, the opposite of opening the brackets. And then multiply that by x plus b. And that's our final answer. That's our factorization of 5xy minus 8x minus 8b plus 5by. And remember, expanding brackets would mean just the opposite. We'd open up the brackets, we would multiply it out, and eventually we'd tidy up the terms if there was any tidying up to be done to get the final expression. Okay, so we can see in example 5 that we have 3 terms in this expression. So this means that this is going to be the factorization of a quadratic trinomial. Remember, where we have a highest power of x in the question, that's a quadratic expression. So the way we do this is we write down the expression x squared minus 7x minus 18, and we construct 2 sets of brackets underneath that. Each bracket is going to contain 2 terms, and we use what's called the trial and error method to figure out what those terms are going to be, trying to stick very closely to the 3 rules that we've set ourselves for checking the result. The first rule says that the first term of each bracket must multiply to give the x squared. And so we can fill that out straight away. It's very easy to see that x multiplied by x gives us x squared. The second term in each bracket are going to multiply to give 18. And so there's different factors that can multiply to give 18. So we'll just write them down on the side of the page. We could have 18 multiplied by 1, we could have 9 multiplied by 2, or we could have 6 multiplied by 3. And what I know for certain is one of these pairs is going to go in the second part of each bracket. The final check I'm going to do is that the product of the inner 2 terms, the inner 2 terms multiplied by each other, combined with the product of the outer 2 terms, the outer 2 terms multiplied by each other, will give me the minus 7x. So the n terms have to multiply to give 18, but then somehow combine to give the minus 7. So we're just going to see how that matches up. We're going to pick an incorrect solution initially just to check our trial and error method. So what we're going to do is let's just put in 18 and 1, which I know to be incorrect. So put down an 18 in the first bracket and a 1 in the second bracket. Let's try the 3 checks that we have to make. The first check is the first part of each bracket multiplied to give x squared. X by x is x squared, so that works. The second check is that the second part of each bracket multiplied to give 18. 18 times 1 is 18. The last check is that the product of the inner 2, 18x, and the product of the outer 2, 1x, have to somehow combine to give minus 7. And there's no way that 18x can combine with 1x to give minus 7. So let's erase the 18 and the 1, and we'll try one of the other pairs. So I know that 18 and 1 is not the correct pair for this. I'm going to try 9 and 2, so I'll put 9 in the first bracket and 2 in the second bracket. And probably most people will have seen very early on when they wrote down the sum that 9 and 2 will combine to give the 7. So let's do the 3 checks again. X by x is x squared, that's fine. 9 times 2 is 18, that's fine. And then the product of the inner 2, 9x, and the product of the outer 2, 2x, they can combine to give minus 7x. Now to figure out the signs, let's write down 9x and 2x, and underneath that we need to try and make minus 7x. So if I had a minus 9x plus a 2x, that would give me minus 7x. And so the signs that go in the bracket are minus 9 and plus 2. That would give me the minus 9x plus the 2x, which would make my minus 7x. So really quickly, just to run through the 3 steps again. The first term in each bracket multiplied to give x squared. X by x is x squared, that's good. The last term in each bracket multiplied to give 18. 9 by 2 is 18, that's good. And then the product of the inner 2, minus 9x, added to the product of the outer 2 plus 2x, give us minus 7x, which is also true. Most people will come along and see their quadratic minus x squared minus 7x minus 18 and straight away be able to do two sets of brackets, put in an x, a 9 and a 2, a minus and a plus, without having to do this rough work in the middle here. But it's just for those people who are looking for a system that always works once you satisfy the 3 checks. This is a system that you can work through to improve your skills and get you better and better at them. So in example 6, we can see again that we have 3 terms. So again, this is going to be the factorization of a quadratic trinomial. We're going to write down the term as we did before, 3x squared plus 4x minus 4, and then immediately underneath it we do 2 sets of brackets. Again, in this example, the first term in each bracket are going to multiply to give 3x squared, and that's quite obviously 3x and x. Where these questions can get a little trickier is if we have a number in front of the x squared that's not a prime number. So for example, if we had 8x squared, well then we have a combination of either 8x and 1x, but it could also be 4x and 2x. So we're quite happy when we see a prime number at the start of a quadratic, as we know that the first part of each bracket will be fairly straightforward to fill out. We know that the second term in each bracket multiply to give 4. And so what I'm going to do is, over on the side I'm just going to write down 4. So it's either 4 and 1, or it could be 2 and 2. Now remember, it could also be the reverse of these. So if I try 4 and 1 and they don't work, that doesn't mean that 1 and 4 wouldn't work. You have to try those as well. So let's try the incorrect solution first of all. Let's try 4 and 1 and just see why it doesn't work. Let's try our 3 checks for a quadratic. The first check is that the first term in each bracket multiply to give the first term in the expression. 3x by x is 3x squared. That's good. The second check is that the second term in each bracket multiply to give 4. 4 times 1 is 4, so that's good. The last check is that I multiply the inner 2 to give me 4x, and I multiply the outer 2 to give me 3x, and these have to somehow combine to give me the x term in the expression, the 4x. But 4x and 3x will not combine to give me 4x, and so I know that 4 and 1 are not the correct solutions to this factorization. So what I'm going to do is I'm going to try 2 and 2. So again, I'm going to do the 3 checks. 3x by x is 3x squared, 2 times 2 is 4, and then the inner 2 multiplied give me 2x, and the outer 2 multiplied give me 6x. And the question is, can 2x and 6x somehow combine to give 4x? And they can. So to determine the signs, I go over on the side of the page and write down 2x and 6x, and they have to somehow combine to give me plus 4x. So what signs would you give this mini sum so that the 2x and the 6x combine to give plus 4x? Well, it's plus 6 minus 2 would be plus 4. So I can see that the product of the inner should be a minus 2x, and the product of the outer needs to be a plus 6x. So one last time, just to check our 3 steps. 3x by x is 3x squared, 2 times 2 is 4, and then minus 2x plus 6x is plus 4x. People will be able to do these in their head. So a lot of people will come along and do the 2 sets of brackets. They'll very quickly put down 3x and 1x, and then in their head they'll try numbers 4 and 1, 1 and 4, 2 and 2. And hopefully, without having to do too much work on the side of the page, they'll be able to land on 2 and 2 and a minus and a plus. But again, the work in the middle is so we have a system that ensures we always get these kind of sums right if we do our 3 steps at the end. So in example 7, we can see that there's 2 terms in the expression. Both of them are squared numbers, and we can see that they're separated by a minus. And so this is the difference of 2 squares. So quite a straightforward question. Most people find the factorization of the difference of squares very easy. So we write down the expression, which is x squared minus 9, and we do 2 sets of brackets like our previous quadratics. We know that the first term in each bracket is the term that has been squared to give x squared, and so we know that x times x, or x all to be squared, gives me x squared. The second term in each bracket is the term that's been squared to give 9, so we know that 3 squared is 9, or 3 times 3. And then the difference of 2 squares is always a plus and a minus, and it's as easy as that. So there's no great need to check the solution. The difference of 2 squares always has the same terms in each bracket, but just has different signs. Again, some people prefer to write out the following method, and we'll just do it to make sure that people who've seen it this way are happy as well. So x squared is the number or the term x all to be squared. 9 is the term or number 3 to be squared. And then we do the 2 sets of brackets. So some people just like that additional step so they can see that it's going to be x and an x and a 3 and a 3. And then remember, it's always going to be a plus and a minus. So this is an optional step. Some people like to write out that one just to see what the term is being squared. Hopefully people spot in example 8 that this is also the difference of two squares. So we have an expression that is separated by a minus, and both of the terms in the expression are squared terms. So let's again write down our initial expression, 4x squared minus 25y squared. This time what we might do is we might do the second method of the previous example. So what we're going to do is we're going to just write down that 4x squared is 2x all to be squared. Minus 25y squared is minus 5y all to be squared. And then I'm going to put in my 2 sets of brackets. So I can see that the first part of each bracket is the number or term that's going to be squared to give 4x squared, so that's 2x and 2x. And the second term in each bracket is going to be the term that's going to be squared to give 25y squared, 5y by 5y. And then remember, the difference of 2 squared is always a plus and a minus. So I prefer just to go from the top line straight down to write out the bottom line, but some people just prefer to write down the term that's being squared first just to make sure that they don't make any error, I suppose, in the question. So what we've done in the previous 8 examples is we've taken 2 examples of each of the 4 different factorization types we learned at Junior Cert, and we just revised those. What we're going to do in example 9 and 10 is just put a slight twist on those to show where factorization could be used as part of a further or more difficult example. So in example 9, we're asked to factorize fully, and the word fully is important, x cubed minus 25x. On initial inspection, some people might look at it and think it looks a little like the difference of squares, which it does a little, but there's no terms being squared here. X cubed is not a term that has been squared, and whilst 25 is a number that's been squared, 25x isn't something that has been squared. So what we're going to have a look at instead is we're going to have a look at is there a common factor to both of these. And I can see that whilst there's no number common to both x cubed and minus 25x other than 1, we can factor out one of the x's. So if we divide x cubed by x, we get x squared. And if I divide minus 25x by x, I get minus 25. And so we've done some factorization by taking out a common factor. And some people might be happy to leave it at that. And we have factorized the expression, but we just haven't factorized it fully. Hopefully people notice that within the bracket, we have the difference of 2 squares. And so what I'm going to do is I'm going to leave x outside of the first bracket. And then with the difference of 2 squares, remember we do 2 brackets underneath it like that. I know that in the difference of 2 squares, the first part of each bracket is the term being squared to give the x squared. So that's x by x. And then in the second part of each bracket, it's the term being squared to give a 25. And that's obviously going to be a 5 and a 5. And remember, the difference of 2 squares is always a plus and a minus. So this is a combination factorizing question. We've done a common factor initially, and then we had a part 2 where we had the difference of 2 squares. And if you'd like to see more of that type of question, you can look in the trickier question pack that's about to follow example 10. Now, if we were to multiply all this back together, we would get the x cubed minus 25x. We'd multiply x plus 5 by x minus 5 initially, and then whatever the result of that was, we could multiply in the x by it then. Or we could multiply the x by the x plus 5, and whatever the result of that is, we could open up a bracket and multiply that by the x minus 5. So multiple ways to multiply it back out. If you wanted to practice your multiplication, it would be a good exercise to multiply this back out and see do you indeed get to the x cubed minus 25x. So example 10 asks us to simplify 2x plus 2y over x squared minus y squared. So this is one of the beauties of factorization that can allow us to simplify a fraction like this, which without factorization we'd have no way of dividing the x squared minus y squared into the 2x plus 2y to make this any simpler than it is at the minute. So what I'm going to do is I'm going to factorize both the top and the bottom of the expressions. I can see that the top will be factorized by a common factor, the common factor being 2, which we'll use in a second. And then I can see that the bottom is the difference of 2 squares. So let's perform that factorization on both the top and the bottom and see what happens after that. So on the top, I'm going to factorize out the 2, and if I divide 2 into 2x, I get x, and if I divide 2 into plus 2y, I get plus y. The difference 2 squares is always very straightforward. X squared minus y squared, I'll do 2 sets of brackets. The first term in each bracket is going to be the term that multiplies to give x squared, so x by x. The second term in each bracket is going to be the term that multiplies to give y squared, so y by y. And remember, the difference 2 squared is always a plus and a minus. Now, we're left with 2 on x plus y over x plus y on x minus y. Now, if I was to divide the bottom and the top of this expression by x plus y, that will remove the x plus y's, and I'll be left with 2 on the top and x minus y on the bottom. So I've taken an expression that's quite complex, 2x plus 2y over x squared minus y squared, and by performing factorization on the top and the bottom, I was able to simplify it or break it down into 2 over x minus y. So a lot to digest there in terms of those 10 examples that cover the main types of factorization we would have seen at junior cert level. To see where we might apply it to the Leaving Cert or to push on the difficulty level a small bit, you can try the 10 trickier questions that are to follow. As usual, I'd suggest pausing the video and going and trying those 10 trickier exercises before you look at the work solutions, and then coming back, watching the work solutions and seeing what you already knew, or making corrections to the mistakes that you made in the question. Okay, so let's take a look at 10 further examples of factorization questions. So these are trickier either because they've been taken from higher difficulty level junior cert higher level questions, or because they've been adapted from a Leaving Cert higher level question where the difficulty isn't actually in factorizing the expression, but perhaps in forming the expression sometime earlier in the question. And that's the case with our first question here. So our first factorization here comes from a topic called proof by induction. So this is not a topic we'll have seen at junior cert level, so don't worry if you are unfamiliar with the title, proof by induction. But it's a topic that people generally find quite difficult at Leaving Cert higher level. So we'll have done some work in a question and we'll have ended up with the expression 3k squared plus 5k plus 2, which we now have to factorize. So it's a quadratic trinomial, so if we write it down, first of all, 3k squared plus 5k plus 2. We'll notice that there's k's in the question as opposed to x's. Proof by induction often uses k's in the question, so that's not unusual in this type of a problem. And to factorize a quadratic such as this, what we're going to do is we're going to open up 2 sets of brackets. We know that the first term in each bracket is going to be the 2 terms that multiply to give 3k squared. So the only terms that multiply to give 3k squared are 3k and k. I know that the second term in each bracket is going to multiply to give 2. So if I write down 2 first of all, and then write down the factors of 2. So it's either going to be 2 by 1, or it could be the reverse. It could be 1 times 2. And in this problem, it's unusual because both of those pairs seem to work, and we'll see in a second why only one of them is the correct solution. So we're going to try the incorrect solution first of all, which is a 1 and a 2 in the end parts of each bracket. Let's see why this doesn't work. So we always have 3 tests which we have to pass for this to be a correct factorization. So the first test is that the first term in each bracket multiply to give 3k squared. So 3k times k is 3k squared, so that's correct. The second rule is that the second term in each bracket has to multiply to give 2. So 1 times 2 is 2. So it's passed the first 2 tests. The third test is that we find the product of the inner 2, which is 1k, and the product of the outer 2, which is 6k, and they have to somehow combine to give 5k. Now, if I write down k and 6k, it does appear that they could combine to give 5k, but they actually can't combine in the correct way here to give plus 5k, and here's the reason why. If we wanted to make plus 5k, we'd have to have a plus 6 and a minus k. And if I put in a plus 6, that's the outer terms, so the 2, and a minus k, which is the inner terms, so the minus 1, what we have is that it seems to pass the test, but it fails on one of them, which we'll see in a second. So 3k by k is 3k squared, that's fine. Now minus 1 times plus 2 is minus 2, and we need to have plus 2 as our final term in our expression. And so we can't have a minus by a plus in the brackets. So that's the test on which this fails. The third test it passes. The inner terms would multiply to give minus 1k, the outer would multiply to give 6k, and 6k minus 1k is plus 5k. So sometimes it seems like a quadratic satisfies all the conditions, but you have to be really careful with our signs. And so the second test, where we multiply the n terms in each bracket, minus 1 times plus 2 is minus 2, and we need to have it equal to plus 2. So it's not going to be minus 1 plus 2. So let's get rid of those. And we know that it has to multiply by 2, so it must be the reverse. It must be 2 times 1. And let's test this. So the first term in each bracket, 3k by k, gives us 3k squared. That's fine. The second term in each bracket, 2 by 1, gives us 2. That's fine. And then the inner 2 multiplied give us 2k. And the outer 2 multiplied give us 3k. And again, 2k and 3k can combine to give plus 5k if we add the two of them. So if I give both brackets a plus, we'll finally get to the solution, which is 3k plus 2 on k plus 1. Now to do the three tests quickly again, the first part of each bracket, 3k by k is 3k squared. Second part of each bracket, 2 by 1 is 2. And then the inner 2, 2k, added to the outer 2, 3k, they will give us 5k. So a lot of people can come along and do all that work in their head, which is fine. Some people may need a pencil and use trial and error with rubbing out some of the incorrect solutions and trying them again to make sure that you land on the right factorization. Okay, so the second question has been adapted from a Leaving Cert higher level algebra question. So this was a question on simultaneous equations, so not of the type that we would have seen in our junior cert. This is a type of simultaneous equation where we would have had a linear equation combined with what's called a non-linear equation. So again, we're not overly concerned with where it comes from, but at some stage during the question, we would have to factorize this expression that we formed, which is that 7b squared plus 5b minus 2. So the factorization of this is a quadratic. The highest power of b in this question is 2. And so we'll write down two sets of brackets. The rule is that the first term in each bracket multiply to give 7b squared. This is quite an easy one because 7 is a prime number. The only numbers that multiply to give 7 are 7 and 1. And so we know that the first term in each bracket is 7b multiplied by b. The second term in each bracket multiply to give 2. So we know that it has to be 2 times 1, but it could also be the reverse of that. So it could be 1 times 2. So we'll just try 2 times 1 and we'll run through our 3 checks to see if this is the correct factorization. So the first check, we know that 7b times b is 7b squared. The second check, we know that 2 times 1 is 2. And the third check, we're going to multiply the inner terms to give us 2b and the outer terms to give me 7b. And we have to see, can 2b and 7b somehow combine to give me plus 5b. So I'll write down 2b and 7b and then plus 5b. And the question is, how do I combine these terms to make a plus 5b? So if I have plus 7 minus 2, that will give me plus 5. So the inner terms is a minus 2b and the outer terms is a plus 7b. So plus 7 minus 2 will give me plus 5b. So just to check the solution one more time, 7b by b is 7b squared. Minus 2 times plus 1 is minus 2. And then finally minus 2b, the inner product, plus 7b, the outer product, is plus 5b. And so the factorization here, if we just write it over on the right hand side again, is 7b minus 2 on b plus 1. And in this Leaving Cert algebra question, there was further work then to be done with that factorization. Okay, example 3 is an example we wouldn't have seen in the basic examples, but again, it's a combination of factorizing types. So we have the expression x cubed plus 2x squared minus 3x, and it says to factorize fully this expression. So the first thing that I can see is that there's an x in each of the 3 terms, and so I'm going to factorize out an x using common factor of x. If I divide x cubed by x, I get x squared. Plus, if I divide 2x squared by x, I get 2x. Minus, if I divide minus 3x by x, I get minus 3. And I'm going to close the bracket. So what I did initially was, I just took out a common factor of x. So some people might spot now that the bracket we've created has a quadratic within it. And so we can further factorize that quadratic by opening up two sets of brackets. So we have an x outside, and then inside the two sets of brackets, we're just going to factorize x squared plus 2x minus 3. The only two terms that multiply to give x squared are x and x. And then I know that the last term in each bracket has to multiply to give 3. And the only things that multiply to give 3 are 3 by 1. Because it's an x at the start of both brackets, it doesn't matter if it's 1 by 3 or 3 by 1. So I can just stick them in as they are. And I know that they're the correct terms for these brackets. I'm just not sure of the signs yet. So the first test is x by x is x squared. The second test is 3 by 1 is 3. And the last test is that the product of the inner two, 3x, combined with the product of the outer two, 1x, have to give me plus 2x. So if I have a 3x and a 1x, how can they combine to give me a plus 2x? Well, I'll need to have a plus 3 and a minus 1x. So it's a plus 3x for the inner terms, and then the outer terms is a minus 1x. Now, let's just finally go through the factorization of the quadratic again. X by x is x squared, 3 by minus 1 is minus 3, and then plus 3x minus 1x, the inner combined with the outer gives us plus 2x. And so this is the final factorization. So this expression factorized into three terms: x multiplied by x plus 3 multiplied by x minus 1. So example 4 is an example where we have to simplify a fraction. And so what this means is we need to factorize both the top of the expression and the bottom of the expression. So the top of the expression is factorized through a common factor, and I can see that that common factor will be 4. And then the bottom of the expression is the difference of two squares. So the difference of two squares. Okay, so on top I'm going to factorize out to 4. So 4x minus 4 becomes 4 on x minus 1. And then on the bottom, the difference of two squares, I have two sets of brackets. So x is being squared to give me x squared, so it's x and an x in the opening of each bracket. And then 1 is being squared to give me 1, and so it's a 1 by a 1 in the latter part of each bracket. I know that the difference of two squares always has a plus and a minus. Finally, what I'm going to do is I can see that there's a common term on the bottom and the top, so I have an x minus 1 on the top and an x minus 1 on the bottom, so I'm going to divide the bottom and the top by x minus 1, and then my final answer is that this simplifies to 4 over x plus 1. So example 5 is probably the trickiest example we have. So it consists of two parts. In the first part, we're asked to factorize a to the power of 4. So a to the power of 4 minus b to the power of 4. Now, on first glance, it's not immediately apparent what kind of a factorization this is. There's no term common to both of these. It's clearly not a quadratic. And so if we look at it closely enough, we might spot that this is going to be the difference of two squares. Now, someone might say, this is to the power of 4 and not squared. But if you think about a to the power of 4, a to the power of 4 is a squared squared. So a squared is the term being squared to give a to the power of 4. Similarly, the power being squared to give b to the power of 4 is b squared. So b to the power of 4 is b squared squared. Now, to perform factorization on the difference of two squared, I have two sets of brackets. The first term being squared, which is a squared, goes in the first part of each bracket. And the second term that's being squared, b squared, that goes in the second part of each bracket. We know that the difference of two squareds is always a plus and a minus. So this is a correct factorization of a to the power 4 minus b to the power 4, but it says to express this as the product of three factors. This is only two factors. So the question is, how will I get a third factor out of this? So you might spot that the second bracket has an a squared minus b squared, and a squared minus b squared can be further factorized using the difference of two squares. So I'm going to take the a squared minus b squared, and I'm going to perform factorization using two further sets of brackets. So the difference of two squares, remember, the first term in each bracket is going to be the term squared to give a squared, so that's a by a. The second term in each bracket is going to be the term squared to give b squared, so that's b times b. And then we know that this is always going to be a plus and a minus for the difference of two squares. So we were able to take a to the power 4 minus b to the power 4 and factorize it fully to be a squared plus b squared on a plus b on a minus b, which is the product of 1, 2, 3 different factors. The second part of the question asks us to factorize a to the power 5 minus a to the power of 4b minus a b to the power of 4 plus b to the power of 5. And again, on first look, this looks like a very tricky factorization. There's no term common to all of the parts. There's 4 terms, and so we might try factor by grouping. So let's first look at what might be a common factor to a to the power of 5 minus a to the power of 4 times b. And the common factor is a to the power of 4. If we divide a to the power of 5 by a to the power of 4, we get a. And if we divide a to the power of 4b by a to the power of 4, we get b. So that's the first pair factorized. Then I'm going to take the second pair, and I can see that the common factor in the second pair is minus b to the power of 4. If I have minus a b to the power of 4, and I divide minus b to the power of 4 into that, I'm left with a. And if I have b to the power of 5, and I divide minus b to the power of 4 into that, I get minus b. We know that we're on the right track because the two brackets are exactly the same. And so what I'm going to do is I'm going to wrap the a to the power of 4 minus b to the power of 4 into a bracket, so the opposite of open a bracket. And then in the other bracket, I have a minus b. Now, it says to factorize this, and in this bracket we have a to the power of 4 minus b to the power of 4. So we have put it into brackets and it is factorized. But we could factorize it further by now replacing the a to the power of 4 minus b to the power of 4 with the answer from part 1 of the question. Remember, this is the factorization of a to the power of 4 minus b to the power of 4. So I'm going to substitute in a squared plus b squared, bracket a plus b, bracket a minus b, and then remember we already have this a minus b in our expression. And then one final line of factorization we could do is we can say a squared plus b squared times a plus b, and then the last two factors, a minus b times a minus b, well, that's a minus b all to b squared. So all three of these last lines are valid factorizations of the expression in part 2. We weren't asked to give it in a particular form, but because in part 1 they had asked us to factorize a to the power 4 minus b to the power 4, it made sense to use that in the last couple of lines of the factorization of part 2. So that's the 5 adapted Leave Insert higher level versions of factorization questions. The examples 6 through 10 are examples taken from Junior Cert higher level papers. So I'd invite people to go and try those and have a look at the printed solutions that are attached in the folder. And if anyone has any trouble with them, get on to me and we can make a video solution for some of those.